Hello, coming back with the next video of yours, right? We are going to start with again another video of linear equations, pair of linear equations in two variables. So already we have discussed all the three methods and important problems. Now today I'm going to discuss about some of the different problems, right, which are reducible to linear equations in fact, and the problems related to the consistency conditions, right, which already we have given you at the beginning only when we discussed the linear equations at the beginning before even solving the problems. Now we are taking some of the problems related to that consistencies, right? Okay, let's begin with the first problem. Comment on the nature of the roots of the following system of equations. So you have to comment on the nature of the roots. I mean, you have to talk about what type of roots will these equations be having, right? Whether it is a unique solution, whether the equation will have infinite number of roots, or whether they will have no roots at all, right? And that too also without proceeding for solving. Am I clear to you? So, and that can be only verified by considering the conditions of consistency. And for that we have to calculate three different ratios, right? That are the ratios of the coefficients, right? So without much delay, we are starting. So anyway, I'll rewrite the question in the standard format. Already they are there in the standard format, but still I'll write the questions. This is x minus 3y minus 3 equal to 0. This is number one. And the other equation is 3x minus 9y minus 2 equals 0. This is number one. So here what I can write, a equals 1, a1 equals 1, b1 equals minus 3, c1 equals minus 3 again, and then a2 equals 3, b2 equals 9, sorry, this is minus 9, and then c2 equals minus 2. Very fine. So but do not forget to write here how did you get these values, right? Because we do not have any a1 a2 present here, right? So you must write that you are comparing this whole thing with the standard form. So once you get this, you go on finding these ratios one by one. You do not find all the ratios at a time, right? First you find what is a1 by a2, that is simply 1 by 3. Fine. Then you go for finding b1 by b2. So what is the value of b1? It is minus 3, then this is minus 9. Ultimately it's equals 1 by 3. So once they are equal, then only you proceed for the third one, right? So as they are equal, we are calculating the third one, that is minus 3 divided by minus 2, giving you 3 by 2. Now we are observing this ratio. What is the conclusion? Clearly you have observed that this is a1 a2 equals b1 b2 not equals c1 c2. Now just remember the first day explanation. What does that mean? This means a set of parallel lines, and when the lines are parallel, what do you say about the number of solutions? Yeah, exactly, they do not process any solution. So what you can write now, uh, therefore therefore the system does not have any solution. So they are asking about the solution, but if they would ask you about the nature of the lines, what did you say? Lines are parallel here in this case. Okay, that's it. Move on to the next. Okay, great. So another equation. Let me put them again in the standard form. Okay, let me again try to mention you that this is also standard form. It's not that it is not a standard form, but as I already have taken everything in the left side from the beginning, I'm considering that as a standard form in my calculations, right? So I'll put this whole equation in that particular format, right? So that I can compare easily what is a1, what is B1, etc. Then this is going to give you this much. Now see, look here, what is A1? Again, I would like to tell you, B1 is A1, B1, B1 is 1. Then what is C1? It's 5. Great. And then what is A2? It's 3. What is B2? It's 2. And what is C2? It's minus 8. Great. So again, I'm telling you, please do not forget to mention here that you compare this with the standard form. That's a very important part you have to remember, right? Okay. Now next, you go on calculating the ratios. A1 by A2. That gives you 2 by 3. Fine. So you cannot reduce it anymore. So you stop there. And then you calculate the next one. B1 by B2. This is 1 upon 2. Okay, fine. What did you observe here? They're not equal. So you do not calculate the third one. It will be useless. So directly, what will write? A1 by A2 is not equal to B1 by B2. That's the very first condition, right? So that first condition implies you what? A pair of intersecting lines. If lines are intersecting, how many solutions? Yeah, exactly. Unique solution, right? So you can write, therefore, the system has unique solution. Great. Okay. Next. Again, the same questions, right? Same type of questions. Here, the first question, I can rewrite this as 3x minus 5y minus 20 equal to 0. Then this is 6x minus 10y minus 40 equal to 0. So what exactly A1, B1, C1 are? A1 is 3, B1 is minus 5 and C1 is minus 20. Great. And A2 is 6, B2 is minus 10 and C2 is 40. Okay. So again, I'll put a question mark here. What you have to write, you already know. I repeated earlier. And then you find the first ratios. Now, okay, I'm not writing the statements here because already in the first problem I have written extensive ones. Okay, this is reduced. Once there is scope of reduction, right? You please bring it to the simplest form. The B1 by B2. This is minus 5. This is minus 10. Reduced to half. Okay. So you have seen that these ratios are equal. So once it is equal, go to the third. Okay. So minus 20 by minus 40 giving you half. Okay. This time what we have observed. Therefore, we saw that A1 by A2 equals B1 by B2 equals C1 by C2. What does that mean? Yeah, all the ratios are equal means the lines are coincidence. How many solutions does this process? Yeah, exactly. Yeah, it will be infinite in numbers, right? So you can write therefore the number of solutions of the system is infinite. That means the system will have infinite number of solutions. Luckily, we have got all the three types here. So let's see what next. Okay, this I leave it to you. You please carry on it as a homework. Definitely, you will not have any problem in doing this. Okay, this is different question, right? Let's do this. Find the value of A and B so that the following system of equation has infinite number of solutions. This time you have to find the value of A and B so that this system will have infinite number of solutions, right? Okay, fine. Anyway, let's start with what we know. First of all, you have to bring this in the standard form. So we brought it down, we rewrite it, right? So this will be also rewritten in the form of the given one what I disclosed earlier. It is minus 3a plus b minus 2. This will be equal to 0. This is number 2. Now can you just write here what is a1? Yeah, you can compare. That is 2. Then b1 is 3 and c1 is minus 7. Great. Now what is A2? Yeah, it's A minus B. And then what is B2? It is A plus B. And what is C2? Yes, it is minus of 3A plus B minus 2. Great. So you have compared everything, right, with the standard form. Again, I'm again mentioning here, this is very important, right? You mentioned that how did you get A1, A2, A3, etc., right? Okay, so now this time mode of workout will be little different. Earlier we calculated the ratios, but this time they already told you that this system has infinite number of solutions, right? So what I can write is, since the number of solutions is infinite, right? Therefore, what you can write? If the solution is infinite in numbers, number of solution is infinite, then you can easily remember that all the ratios must be equal. Great. Now you go on putting all the values, right? Whatever are available, you go on putting. So this is here, and B1 is 3. It is A plus B, and then this is minus 7. This is minus 3A plus B minus 2. You can cancel this to minus, right? Okay, so you got the relations, right? Having three different ratios, this one, and this one. So now your task is to find from these relations only what is the value of A and B. That's the problem left out here, right? So you have to compare each possible pairs, and then you have to generate linear equations in A and B. Okay, let's see how we'll proceed. Okay, so if I compare the first two, okay, now you need to write like comparing first two. You simply write now. You better give a equation number here. Say 1 less. Now 1 less implies I'm going to take the first two ratios, right? 2 divided by a minus b equals 3 divided by a plus b. Now get the cross multiplication done, right? Okay, 3 times of a minus b equals 2 times of a plus b. What you will get? It is 3a minus 3b equals twice a plus 2b. Great. The like terms in one of the side. So 3a, 2a, if you bring to the left side, it will be minus. So you'll be getting a, and this 3b, if that side it goes, it becomes plus, and then this is 5b. Great. So already you got something which can be utilized for substitution. Fine. So whenever next you get any value a, you can substitute in order to find b. Okay. So now you compare another pair. Maybe first and the third, or maybe second and the third. Let me compare the second and the third, right? Okay, there is no logic here or no like fixed rule that you have to compare the first and the third, second and the third, etc. But once I finish it, I'll be telling you that you have to take all the three pairs. Anyway, now here again, before you go for cross multiplication this time, because there is a scope to replace a by 5b, so you replace it here. Otherwise you do the cross multiplication, then you solve that equation with these students. But here I'm lucky that I got a simple substitution. So here in place of a, I'll be putting 5b. So what will I get? 6b. Great. Then minus already I can cancel as I told you earlier. Then 3a, right? 3a means if I put 5b in place of a, it will be 15b, right? 15 plus this will give me 16b, and then minus 2. Okay, so now you get this multiplication done as immediately as possible, right? So I multiply these things first. 16 3s are 48b, then 3 2s are 6, then 7, this is 42b. So what exactly you'll be getting now? B. So if you bring down this 42 to the left side, you'll be getting 6b equals 6, then giving you b equals 1. Great. So you got b equal to 1, and what is a equals? A equals in that case 5. So you got two values of a and b, and that's what we are asking for. But remember, there's a very important issue now. You have compared only first two ratios and the second two ratios. What about the first and the third? Will they be giving you the same value? Right? So that's a big question. And therefore, I would suggest you again, once you find this value, do not be satisfied. Now, put this value in the first and the third part of the ratios, and then you check whether they are equal or not. Right? This value should be same once you put this value. Right? Okay, move on to the next. Yeah, same type of question. This time only one unknown is there, that is k, and the system has no solutions. No solutions, right? Anyway, I'll be doing this. We'll be bringing it to the standard form, right? More you practice, more you will be getting exposure to different problems and different types, and your skill will be developed. So please do practice. So here a1 equals 3, b1 equals 1, c1 equals minus 1. What is a2 equals? It is 2k minus 1. b2 will be equal to k minus 1, and c2 is equal to minus 1 times 2k plus 1. Great. So again, I would like to remind you, have to write the reason here. Here, what I should write? For no solutions. For no solutions, what is the condition? I have to accommodate here. The condition is that a1 by a2 equals b1 by b2, not equal to c1 by c2. Okay, let me just try to tell you, bring the habit when you do the practice. Once you write these conditions of consistency where no solution is there, immediately you try to see through your mind's eye what exactly were the graphical representations, right? So here, as they are talking about no solution, it means the lines in graph were parallel, right? Okay, let's put the value and proceed for finding the value of the unknown, what they are asking, right? So we'll be putting the values. This is not equal, minus, then minus 2k plus 1. This minus will get cancelled. So again, here you got another equation, one less. If you'd like to write it as 3, you can write the equation number. Again, the same thing, you consider all the 3 pairs, right? Now we'll be considering one at a time. Now one less implies I would like to consider the first 2 equations first. Okay, do the cross multiplication. What will it give? It is 3k minus 3. That means this multiplication I did first equal to 2k minus 1. Then this 2k you bring this side, it will be giving you k. 3 this side, it will become plus, and then it will be 2. So anyway, the first step gives you the value of k. But remember, this may not be the exact value. So you have to proceed for comparing the other pairs too. So this time we are going to compare the second two pairs, right? 1 by k minus 1. The comparison will be what? Not equal, right? Be very, very alert. By chance, if you write it wrong, everything will be spoiled. Again, we did the cross multiplication. So this time, this value of k, I'll bring this side. K will be there. This I'll take that side, minus 2. It's not, right? Remember, this means a lot to the complete answer. So here you say, how do you justify? You got k equal to 2, right? Now that is being supported by this particular statement. So k not equal to minus 2 tells you that if you consider something which is k and it is not equal to 2, then this particular system might be having no solution, right? That means the value you get must not be equal to minus 2. And now you check whether the value you got is equal to minus 2. No, it's not minus 2, right? So that is acceptable value. You got the logic? But remember, here you have to verify the third pair also. Third pair means this, because if this will lead you to something else, then there will be a real genuine problem arising. So this should also give something which is telling you that k is equal to 2. Got it? So you should solve this also. So I am solving this. Let's see what it gets. It is going to tell me. So that is 4 not equal to -4. So k should not be equal to 1. That means whatever values of k I get, it doesn't make anything, but it should not be equal to -1 and -2. This is the conclusion. And then the third, that is the first of our calculation, gives us what is the exact value of k. That's it. That is k equal to 2. Great. That's an important question. Please do see it, practice it, try to understand it. Proceed further. Yeah. Solve the equations. Right? Solve the system of linear equations. Now let me again try to tell you that at the beginning only today I told you that we are going to take some equations which are reducible to linear equations. So these are the equations, right? These are the equations. So these are the equations which are reducible to linear equation in two variables. They are not actually linear equations, right? But their form is linear equations. Am I clear to you? So we are going to solve it. Let me try to tell you, once we get these kind of problems, I'll take up the third method, that is method of cross multiplications. So for applying that, I must put them in the standard form. So standard form means everything should be in the left side. First of all, I'll write it in this form. I'll make you understand how I'm going to apply the cross multiplication. Okay, this is small y, right? Typing error. It is minus of 13 by 6. If you like to make it fraction free, that you can do, right? So I'm not trying to do that. Let it be fraction only, because sometimes you have to work on fraction. You do not have any other option left. So let us practice on that, right? Now you see what exactly is a normal practice. I'm not going to use the normal practice because it may take a little more time. Okay, so you practice the way I explain here if you are convenient. Really convenient. Okay, normally what we suggest, you consider 1 by x equal to u, and then 1 by y equal to v, and the whole equation you reduce to the kind of linear equations, and then you proceed. And once you get the value of u and v, you revert that, take the reciprocal, you get the value of x and y. But absolutely I'm not going to use that. Okay, so here how do I visualize this problem? You try to see. I'll do a little rough work here. 1 by twice x, I would like to visualize it as half times 1 by x. So earlier I had x here, but this time I'm having 1 by x. So what I do is that earlier when I applied cross multiplication method, in the numerator I wrote x and below something. This time in mind side I'll consider this is 1 by x, right? Mind side I'll write it as 1 by x, but I'll compare this with x. So whenever you will write the method of cross multiplications, that important relation, you will write in place of x 1 by x. Did you get me? And obviously whatever is the multiplier, that is the coefficient. So coefficient can be fraction, coefficient can be anything. So there is no restrictions here. So here if we compare, what is a1 I can write? Can you directly write? It is half. What is b1 you can write? 1 by 3. What is c1? Minus 2. Great. And then a2 is 1 by 3. And then b2 is minus half. And c2 is minus 13 by 16. So again I would like to tell you, okay, here you do not write, because here you did not reduce it to the linear equation in two variables. So after that you write, therefore by method of cross multiplication. So you have used the method of cross multiplication. What we get, this is the part what I was talking about. 1 by x you write, 1 by y you write, and here constant is okay, 1. Great. So how, what is the shortcut I have given you to work on this? Yes, you have to write this. I'm writing it here at the top. You have to write this in the order, repeating the first once more, right? 1 by 3 minus half. This is minus 13 by 6, and then this is 1 by 3. So the first you have to omit in order to write what is the quantity below 1 by x. So these things 1 by 3 into minus 13 by 6. What will it give? Minus 13 by 18. Minus 13 by 18. And minus, this will give you 1. Right? Great. And for y, you will multiply this to minus 2 by 3. Then minus from the formula. And then this is going to give you plus quantity 1 by 13 by 12. Right? It will be 13 by 12. At last it is minus 1 by 4 and then minus 1 by 9. Great. 1 by x, you work it out. Minus 18, then how much it is? If I minus it 18, it is 31, right? And then this you take the LCM, this will be 12. So 4 times minus 8, it will be 5, and then this will be giving you 36 as LCM minus 30, right? Minus 30. Did I carry any mistake here by chance in the first multiplication? Because I'm getting a little doubt here. It's 1 by 3 into this 18. Okay, anyway, if any mistake will be there, please do the needful, make the correction. Just try to understand what exactly is the process. So now you see, you are going to compare this. You're going to compare this whole thing. You do not try to simplify right at this moment anything, otherwise it may be confusing, right? So I'm giving the possible simplest way where you will omit all mistakes. This is one of the comparison. Then 1 by y, it is 5 by 12 compared to 1 by minus 13 by 36. That's great. So after that, what I told when it was x, I simply told that this quantity has to be put directly over here and simplified. So here, see, I'm writing some dragon's tail like this due to the lack of space. So directly 1 by x, because this quantity I'll take here, 1 by x will be equal to minus 31 by 18, and then here it is minus 13 by 36, and we get the simplifications, right? So the numerator fraction remains as it is, denominator fraction becomes the reciprocal, so 36 will go up and 13 will be here, 18 will cut it by 2, both the minus itself will become plus. So you got this answer as 62 by 13. I have little doubt whether I did it correct or not. Please see once the calculations. So you got 1 by x equal to these things. So what will be x? Just you take the reciprocal, right? In a similar way you find y. That's the idea. That's the idea how you proceed for solving this. Okay, take a little time and then you see, and please do verify my calculations. But you try to understand the process, and I would definitely suggest you to go for method of cross multiplication for this kind of problems. Okay, do not replace it by 1 by x equal to u, 1 by p, or etc. Like that. This is useless. Okay. Yeah, that's one more problem I'm going to take from today. I'll be taking one more class of linear equations. Right? Actually, I have avoided a graphical method that also I'll be discussing, but after a couple of days. So first, let me finish with the problems. Right? We'll be taking one more class, taking the segment problems, which are important. Okay, here also, this problem I'm going to leave you in halfway, right? So you reduce this in the standard form, right? So once you reduce this to the standard form, we get it here like this. So you can compare what is a1. A1 will be 4, right? B1 will be 3, C1 will be 14, and then what is a2 equals 3, b2 equals, it's 4y, so it is minus 4, and c2 is 23, right? So this time by method of cross multiplication, what will write? By method of cross multiplication. Remember, this time both the variables are not in the reciprocal form, so do not be in temptation that earlier what we did, we have to do here also. It's only 1 by x here, and then y will be as it is here, then 1. Great. Now what you'll write here? I do not want to write rough book here, you can do it. So it will be 23 into 3, it will be 69 minus 4 and 4 are 56. Then next will be minus 42 minus it is 23 92 plus 92, and then we'll be getting this is minus 16 minus 9. Great. So 1 by x. So you can work it out, right? If you work it out, 69 is 70, 70 plus 50, 128. It is no 125. And then y, this is 50. And then 1, this is minus 25. So here, after that, what will I get? You will compare 1 by x minus 125 with 1 by minus this, and then y by 50 you will compare by this. Now from here what will get? 1 by x, simply minus 125 you bring up here, it will cut it by 5, so x will be equal to how much? 1 by 5, and this will be giving you y equal to minus 2. Great, fine, that's all. So we finish it today with this problem. See you in the next video, just for finding some important problems with statements, and then we'll end up with this chapter, and then we'll go forward to the next chapter, maybe trigonometry, right? Okay, bye.